Yes, thank you. Let me share my screen first. I believe everyone can see that. So yeah, thanks everyone for having me. And today I'll be talking a little bit about the Cathedral, the Bazaar, and the Central Park, technical challenges in the DeFi ecosystem. Before I start, first, just a quick introduction of myself. I'm the head of engineering at the Maker Foundation. I joined in November 2017. I've been working with my teams on the DAI stablecoin ever since. And I've been involved with blockchain and Ethereum since early 2016. My background is in software architecture and computer science. So I want to start with the DAI stablecoin and what exactly that entails. Now, what we do is that we try to build a decentralized stablecoin with an open ecosystem, as we call it. And throughout this presentation, I want to dig deeper into what exactly we mean by decentralization and openness in this context. Now, on a high level, on a user point of view, from a user point of view, it's actually quite clear what this means. We mean that we have an open ecosystem that everyone can participate, and that that is not just the end user, the user of the DAI stablecoin, but also developers who are building new products and even businesses and industries on top of this open protocol. Now, I want to relate this to open source development. So is this open source software development? Well, the business logic of the Maker and the DAI protocol is completely implemented as smart contracts code. And this code is freely available. The Ethereum blockchain runs that code, and it really acts as the world computer. These days, this term is not as popular anymore, but for the purpose of this presentation, I think it is a good metaphor to work with. Now, as I mentioned, the source code of the contracts, it's open source. It is permissionless once it is deployed to the Ethereum blockchain. And last but not least, it's also verifiable. So as a user, you can actually verify that the code that will be run is indeed exactly the source code that has been shared through the open source version control system, typically. Now, this is clearly open source, but the question is, how are open source and decentralization related? There definitely is an intuitive relation between openness and decentralization. So this is where the Cathedral, the Bazaar, and the Central Park come into play. So these are metaphors, and yeah, I would like to go through these with you to explore how open source theory really applies to blockchain development. Now, first things first, the Cathedral and the Bazaar. People with a computer science background on the call may already recognize this, because this is the title of an iconic essay by Eric Raymond, which really talks about open source software development. And there are two models that Eric Raymond distinguishes between. One is the Cathedral model, and the other is the Bazaar. Now, the Cathedral model is a form of open source software development where the source code is publicly available, but the development of it is centralized, and it's very much restricted and controlled by a centralized party. So although the software is open and free to use, there is very much in development a top-down dynamics. It does, however, achieve one of the advantages of open source software, which is security through transparency. And this is also the point made by Eric Raymond, is that security in open source software depends on its open character. So the assumption is that as the software is open to inspect for everyone, that a lot more developers will look into the software, may want to participate, and will also, of course, detect vulnerabilities and bugs. And the way he put it was saying, given enough eyeballs, all bugs are shallow. You will find most bugs if you have many people looking at the source code. But as I mentioned, this Cathedral model is really centralized and restricted in terms of its development. So this is not really a good fit for the DeFi ecosystem and how that is developed. So what about the Bazaar? The Bazaar model is different in that it's decentralized and loose collaboration between individuals. This is how the development happens. The source code lives on an online source control system, and any developer with internet access really is invited to participate in this development. There's very much a bottom-up dynamics. If you use the software as a developer, it doesn't have the right feature that you want. It's very easy. You can either write that feature yourself, or you can collaborate with other developers in the ecosystem to create that feature. And the most famous example of this is the Linux operating system. So this is not just small software, it's also software that is really secure. So we can see that the security model of the open source software development methodology really works well, and or at least can work well in this particular case in particular. Now, is this then a good model for DeFi software? Well, I would argue that traditional open source software models, they focus mostly on the development process. But for DeFi, in order to understand the decentralized nature exactly of it, we need to also look at the runtime environment. And the runtime environment isn't really mentioned in the Cathedral and the Bazaar models, because it is silently assumed to be under central control. So for example, if we take Linux again, if you are running Linux, you will deploy it on your own server. So what does that mean? As you see in the diagram below, the developer community, very much decentralized. They will build the open source software and multiple versions of it. And then these versions are deployed to servers that are controlled each by their own system admin. So there really is no decentralized control in the runtime environment. Decentralization in open source software traditionally really much applies to the developer community and not the software itself. Now, if you compare that to the Maker protocol, then that is very different. The Maker protocol is not like Linux in the sense that there is only one Maker protocol that is deployed on the Ethereum blockchain. Yet we say that it's very much decentralized. So what do we mean by that? So this is where I argue that maybe a better metaphor for this kind of software, for DeFi software, is the central park. Now, why is that? Well, the Ethereum World Computer is a decentralized runtime environment. And now we are looking at that runtime environment. DeFi protocols running on top of that environment, they resemble the central park in that they are open and public infrastructure. And this goes, of course, back to the original value proposition, is that any user is free to participate, be it an end user of the DAI stablecoin, or be it the developer in the ecosystem. It is, however, centralized in the sense that everyone shares the same space. I'll go into the details of the system in a minute, but the Maker system is basically a lending platform. And if, as a user, you are taking out DAI, then you are really communicating with the same protocol as any other DAI user. So there is only one business logic, really, that applies to everyone, and everyone is in the same space. Ultimately, however, the protocol is controlled by voters. And this is very different from what we saw with the Bazaar model. Any Linux server is controlled by its own system administrator. And this is important because the system administrator controls the environment, and they decide, for example, when they upgrade the software, which version of the software that they want to run. And sorry. And if they want, they can make changes to the environment that are specifically suited to their own specific needs. Now, in DeFi, you can't do that. Everyone shares the same space. If I change, or if decentralized governance changes something in the protocol, then this change will apply to everyone. But of course, not any individual can do that. This is really controlled by the decentralized governance system, which is why we say that it's ultimately controlled by the voters. There is also a decentralized developer ecosystem, and in that sense, it is very similar to what we've seen with the Bazaar model. So to put this to a bit more detail, or to recap, we have our decentralized development environment or community. What happens with the code that the community releases is that ultimately it ends up in the runtime environment, which is the Ethereum blockchain. And it is deployed through decentralized governance. So these are the MKR voters. I will come back to that. And they decide that they want to, for example, deploy an upgrade of the system. Now, this upgrade is added to the contracts that are the existing contracts that are already deployed on the blockchain, and they result in the same transparent but centralized business logic as users are used to. So we often call it decentralized because all this is running on a decentralized blockchain infrastructure, and it's often this aspect that is stressed. But what I want to talk about today is mostly the technical challenges that mostly come forward from the combination of the decentralized governance with the centralized business logic. Of course, the public availability applies also in this case. So as I mentioned, all users are free to participate in the system. So what is how does the Maker protocol, for example, what does it look like? On the right side, I have an extremely simple representation of it, but it contains the core of it, really. So we have, in the middle, we have the core protocol, which is the engine that has been deployed to the blockchain from the beginning. And conceptually speaking, really, there are 4 different areas of functionality that interact with that core. The Maker protocol is a decentralized lending protocol, and the way that happens is that if you have a borrower, they can lock in their collateral in the collateral subsystem, and against that collateral, which is typically a cryptocurrency asset, against that collateral, they can take out a loan, and that loan will be paid out by the protocol minting the DAI stablecoin. And the DAI stablecoin can then be used for whatever the end user wants to use it on the blockchain. There is a mechanism here which pushes or pegs the DAI to $1, and the basics of that ultimately is a supply and demand mechanism. I won't go into detail here, but the point is that you need a decentralized governance layer that will set certain parameters on the protocol, similar to a central bank setting interest rates. And the decentralized governance layer, they are controlled by the MKR holders. The MKR is the second next to the DAI stablecoin itself. And then one last element to mention here is the auction system. One way that the stabilization mechanism works is that the collateral that is locked in by the borrower the value of that is tracked by the system. And the system ensures that at any point in time, every DAI token in circulation is backed by at least $1 worth of collateral. Now, what happens if the volatile collateral drops below a certain level, then the borrower deposition is liquidated. And this goes through the auction system. And that's where the what we call the liquidation keepers come in. So they will buy up the collateral and return DAI to the system, once again ensuring that every DAI token in circulation is backed by at least $1 in collateral assets. Now, what do we have to make of this in terms of decentralization and openness? There is no centralized custody in this case. There is no single party that is responsible for custodying the collateral. It just sits there in the smart contract and plays by the smart contract's rules. Public access to all the functionality, so the source code and the governance, everything is open to the ecosystem that is built around the Maker protocol. The business logic itself, of course, is only changeable through decentralized governance. So no single party controls that. And yeah, it's important to notice, and here we get into the technical challenges, that this also applies to bug fixes. So in this sense, code is not always law. If there is a bug in the system that exhibits unwanted behavior, then decentralized governance can deploy a fix for that, but it has to go through decentralized governance control. And of course, our users, as always in blockchain, they can be human, but at many times there are actually other smart contracts or services interacting with the smart contracts. I see that there are a few chat messages, so let me have a look. Yeah, no relevant questions so far, so I'll continue. So what about the technical challenges that really come forth from this public central space, as I mentioned, under decentralized control? There are a few technical challenges that I'll highlight here. One is security, talk a bit about prevention and mitigation. One is upgradability, that I already hinted at, and the other is scalability and performance. And I will try to, every time, make the connection with the public central space under decentralized control. So security and bug fixing first. How well does the open source model work? And how well holds the more eyeballs, the shallower the bugs rule, how well does it hold up? Well, we can see that the Linux operating system, at least, is performing at least as good as the commercial alternatives to it from a closed source world. So for example, if we look throughout the period of 1999 and 2019, then we see that the Ubuntu, for example, if we take that one, that it is close to, well, actually, let me take, for example, Mozilla Firefox. And that one is in numbers quite close to the commercial, let's say, top tier software. And we see that there is an evolution here, because if you look then in 2019, you see that Ubuntu and Fedora, two Linux distributions, they actually have less critical vulnerabilities than, for example, the Windows alternatives. So it's not the case that open source is always more secure than closed source software, but at least we can say that they definitely play in the same league. So in general, we can say that this rule applies. Now, what is the problem with smart contracts? The problem with smart contracts is that once they are deployed, they can only be changed through decentralized governance. And that, of course, it's a high cost, and it means that we need to be absolutely sure that the code that we deploy is as well tested as possible. So in order to prevent bugs, we do not only automated testing, but for example, also formal verification. And of course, we follow the many eyeballs rule. We have smart contract audits that are done, and the community reviews the smart contract code to make sure that as many bugs as possible are caught. On the infrastructure level, we have redundancy, a lot of redundancy. So for example, the Ethereum blockchain, the node implementation of it is no single implementation. There are multiple implementations. For example, the Geth client, Parity client, and many more, to ensure that if there is one bug in one implementation, that we still have the other implementations to fall back to. Also in a network layer, this is the same thing. On the highest level, on the governance level, we also need to be careful that the MKR holders, that they actually vote in favor or aligned with what the protocol needs. So the incentives of the MKR holders, we need to make sure that they are aligned with what the protocol needs, which is modeled by a number of mechanisms in the Maker protocol. So in short, what happens is if the MKR holders, if they set too risky a policy, then they will get punished because the auctions that run the collateral will not bring up enough DAI. So what will happen is that the protocol will then create additional MKR tokens, which will dilute the control that MKR holders or existing MKR holders have over the protocol. In the opposite direction, the borrowers, they pay what we call a stability fee, and this stability fee is used to buy MKR tokens from the market. So that to ensure that if the governance is good, then MKR tokens will become scarcer, and existing MKR holders, they will get more control over the system. Now, regardless of all the prevention mechanisms that we have, there will be bugs. This is a rule in software development that you cannot avoid. So a lot of what we do is focused on mitigation. I have a few examples here. So we have what is called a number of instant access modules. And these instant access modules, they can bypass in certain circumstances the decentralized governance. So this is, for example, necessary for the instant access module that can freeze the price oracles that we use as input. And the reason why that is necessary is because you cannot wait for decentralized governance to take a decision before you have to act in this case. There is also an auction circuit breaker, which ensure that we can stop, auctions can be stopped before the decentralized governance actually reaches a majority. And then I'll actually include emergency shutdown as the next one, because this is the same mechanism. It's an instant access module, in effect, that ensures that a minority of MPR holders can actually trigger emergency shutdown in order to, let's say, have a feasible mitigation strategy to react in case of bugs and vulnerabilities. Another one is the dark fix mechanism, and this one really exists because there is a specific challenge to fixing vulnerabilities on the blockchain with a decentralized governance ecosystem. And the problem is that if the decentralized governance ecosystem, if the MKR holders need to decide whether they want to apply a patch or not, and I will repeat, this is not like Linux. You can't just ask the system admin. So this does have to go through decentralized governance. But if the nature of the vulnerability, and if it's a critical vulnerability, if that nature of the vulnerability is revealed to the MKR holders, then it is also revealed to potential attackers. So this is an issue when it comes to potential critical bugs that might be exploited through the publication of it, and the patch then might actually be too late. So in those extreme circumstances, we have developed a mechanism which is called the dark fix mechanism. And this one is based on explicit trust, where a number of parties are explicitly trusted by the community to look into the matter, to ensure that indeed the patch does fix the issue and does nothing else. And then the governance community can, if it chooses to, put its trust in that third party or third parties and allow them to apply the patch without actually revealing what the patch will be until afterwards, until it has been applied. And then the last one are architectural patterns. And this really, it feeds into the sentence that is at the bottom there. So the only scalable really is to contain and control, because as it says at the other side, there will be bugs. So when the protocol grows, the only way to avoid catastrophic failure is really to make sure that if something happens in one part of the system, that it doesn't affect other parts of the system. And this is one of the key tasks that need to be done by the architectural patterns that you use. Upgradability is the next one. So there is a lot of decentralized control through the upgrades that need to pass governance. We, as we mentioned, governance can only be judged, can be the only judge to separate malicious upgrades from legitimate ones, and it may cause issues with urgency. Once again, this is a shared central space, so upgrades apply to everyone. It affects both users and integrators, and this is very different from running Linux. So in general, immutability is our friend, but this requires a seamless upgrading experience. And how do we provide that with decentralized governance? And last but not least, the scalability and performance. This has various aspects, and I think many of them are well known, so I'll just go over them quickly. You have transactions per second. You have storage of the contract state. You have read performance, because the blockchain is very much optimized for write performance due to the other decentralized requirements that it has. And then you have the developer ecosystem and the quality control, which is also hard to scale up. Of course, there is ongoing research, layer 2 solutions, and in the long term, Ethereum 2.0. So the question I want to leave you with is whether blockchain will actually revolutionize open source software. I think there is a chance that it might, because it is a very interesting combination between open source development and financial incentivization in a sector that is often underfunded, especially the Bazaar model that we talked about. But really, if the central park model will be better in this respect is a multidisciplinary question with no easy answers. So I invite you all to participate in this and help us find a solution to it. I'm pretty sure, because I started with one maxim from software development, so let's end with another one. There will be no silver bullet. Software systems grow faster in size and complexity than methods to handle complexity are invented. So this principle has been known for a long time, and I do think that for blockchain, it will definitely apply for a long time to come.
Well,
and that is it. Thank you.
Yeah, actually, we have few questions in the chat box. If you can pick, we are already near 2-3 minutes left. So just if you can quickly go through them, we will. Jacob Ninan. Jacob, will you like to put your question?
Yeah, I can read it. So Jacob is asking, would DAI smart contracts need to be redeployed if the governance team decides for a software update, and how is the data handled? The answer there is that it depends. So the system is modular. So the governance community, they can add modules, they can remove modules, they can change the configuration of modules. But if you remember the diagram, there is also a core module that really connects all these. So at one point, if the update goes to the core of the system, then a redeployment will be required. And the way that the data is handled is that the users, they will have to migrate from the old system to the new one. Because of the permissionless nature of the blockchain, this is something that governance can't do for them. There are no admin keys to the other question. And then the next one is about formal verification. How well does it work, and how mature is the technology? It is very much a research topic. So it works well enough to catch low-level issues with the code, and that is really important because the blockchain with all the bug bounties and everything, all the collateral that is at risk, it really invites a lot of hackers to look, for example, at the machine code that is executed by the Ethereum virtual machine. Now, on that level, formal verification can check, for example, if there are no overflows, if there are no mistakes, let's say, on the module level. However, when it comes to interaction between modules, then formal verification is still in its infancy, and that's what mostly the research is focused on.
So question, and can you hear me?
Yes.
Okay, yeah, so quick question. Sorry, not too familiar with Ethereum. I work primarily with Bitcoin. But let's say if you were, for whatever reason, need to upgrade the smart contract on chain, right? How is that done specifically in your case? Because every smart contract is different, but in case of Maker, how do you do upgrades if you ever need to? Let's say there's a bug like you spoke or something of the sort. What would be the regular? Has it happened with Maker before, or what's the regular procedure?
So in short, what happens is that the development, what we call the domain team, which is the decentralized community of developers, they will propose a patch, and they can write the code, but they can't execute it. So they need to put up the patch as what we call an executive proposal. And then MKR voters need to vote on that proposal. And if the proposal gets a majority, then the patch is executed and it gets the necessary permissions on the system to apply the changes. So that's basically how it happens. If there is a critical vulnerability, then it may be that we have to use the dark fix mechanism where there is a necessary trust requirement. But actually, this has never happened before. So all the issues that we have identified so far, and there have been, I think, 2 or 3 throughout the 1-year lifetime of multi-collateral DAI now, they have gone through the fully transparent governance process. So this process has proven to be quite sufficient so far. But yeah, we're still, of course, in early times.
I see. All right. Thank you.
Wouter, there is one very interesting question from Utah. It will be great if you can take it. Are you able to see it in the chat box, or shall I read it?
Yeah, already
Yes.
Jacek explained, so I think it's clear enough. But if you have another comment or additional comments, please.
Yes. So the role of the Maker Foundation really was to do the initial development and deployment of the current system, which is the multi-collateral DAI system, and then to facilitate the governance community and the developer community to take over control of that system so that it can run in a fully decentralized fashion. And it's important to notice here that not all stablecoins are created equal. So DAI is quite unique in this nature in that it is designed to be fully decentralized, and it's not really to be compared with, let's say, other stablecoins that have, for example, US dollars in custody. So there is no such thing in the DAI ecosystem because the value is derived from the collateral that is locked up in the system, rather than, let's say, in an off-chain reserve somewhere.
Thank you.
So Wouter, thanks a lot. Now we have reached the end of the second tutorial, and